Hello, I'm going to be solving the CSES problem 1622, creating strings. So let's read it. Given a string, your task is to generate all different strings that can be created using its characters. So the only input line has a string of length n, and each character is between lowercase a and lowercase c. So it's just a normal string. And the output is first print an integer k, the number of strings, and then we have to print k lines, which is the possible strings in alphabetical order. So all of the strings. And in the constraints, we see that the length of the string, which is n, has to be less than or equal to 8 and greater than or equal to 1. So the shortest string is of length 1 and the longest string is of length 8. So in the example here, we see that the input is AABAC. And we can see that it's 5 characters, so n equals 5. And we also notice that there's some repeating characters. So there's going to be some overlap where we're going to be counting the same string multiple times, even though it's just the same character being swapped with each other. So we have to be careful of that. And in the output, we see that there are going to be 20 different combinations of these characters that are unique and are formed by only these characters A, A, B, A, C. And they're also all listed in alphabetical order. So I'm going to be solving this problem using recursion, and I'm going to be showing you how to do that. So first, let's go to a spreadsheet. So what we're going to need is a left side and a right side. So a left section and a right section. Let's put that way over there. And on the left section, first of all, we're going to choose each of the exactly one character from the string we're getting. So let's say that the string we're thinking about right now is just A, B, C. I'm going to put it as the title so you can see it all the time. And then so the first character that you can choose for the left side is basically A, right? The second that you can choose, it here, here, B, and then the third one, C. So we've chosen each of these characters over here, but the thing is, we still have to add each of the characters every time we're going to be calling the function again. So we're going to have to keep on adding this until it becomes a string where each of A and B and C are used, right? So we store the remaining characters over here on the right side. So we say BC, this is AC is left over. On this side, AB is left over. So these are the characters that are left over, and these are the characters that are currently used to create the string. And after A, we have two options. So we can choose to either add B to the string, or we can add C to the string. So we're going to write both of those down. So the left side now becomes AB and AC. So let's say this is the new left side. Now we have two strings of AB and AC. So the characters B and C were added to the original character of A over here. And we're going to be doing the same thing for characters B and C as well. So now it's going to be BA and BC. And CA and CB. And also notice that all of the new left side strings that we have made are all unique. So we make sure that pretty much proves that what we're doing is right. And then we have another new left side. Let me put it here. And here, now the right side is left with only C here. So on this row, we can only add C now. And on this row, we can only add B now. And the right side is changed the same for each of the other strings as well. So this B and this is A. So that means that we have to choose one of the characters on the right side and add it to the left side. So keep on increasing the number of possible strings. But since there's only one character left for each of these strings that you can add, we just add it. So ABC, ACB, BCA, BC, BC, BAC, BCA, CAB, and CBA. And there are your 6 strings that are going to be the possible rearrangements of ABC. So what have we been doing this entire spreadsheet? So what we're doing is we're repeatedly choosing one character from the right side, putting it on the left side, and then repeating that until the left side is filled up with all the 3 characters, or until it's the same length as this, right? So we can use the recursive function to keep on calling itself and keep on adding characters from the right side of the string to the left side of the string. And then we can keep on doing that. So now we know how to use a recursive function. So what we're going to need to do is we're going to, when the length of the right side is 0, then we're going to have to add all the left sides, which are the new string combinations, to some kind of array, and we're going to have to store them all. But the problem is these are going to repeat, okay? Because when we do this, we see that all these A and A and A and A can be swapped here. So these things can be repeated when we use this format. Like we're going to be overcounting a bunch, but we only need to have all the unique strings. So when you think of the word unique, you probably want to think of some kind of set. And we're going to need to use a set in order to organize all of the left sides and then be able to print them out. So I think we can start coding at this point. Okay, so first we import java.util. And then we need a scanner, right, to get the string that we're going to be changing. So static scanner in static int. Actually, we don't need an int. So we do need, however, we need a string s, right? Static string s, which is going to be the string we're getting with the scanner. And then we're going to need a set. But remember that all of these strings that we output have to be in alphabetical order. And something that sorts that for us right away is a tree set, actually, because while it also gets all of the unique values, it also sorts each of its contents. So static tree set, string set would be very helpful in this situation. So public static void main string. We create our main. Then we initialize our scanner, and then we get s. S equals in.next. And then we also initialize the set, right? Set equals new tree set string. And then let's try to create our recursive function here. So static void, let's call it R for recursive. And we're going to have string left and string right. And then here, we're going to need a for loop because we're going to we're going to need to get one character from the right side. Here, what we're doing is we're selecting one character from the right side and bringing it over to the left side to create new strings and adding on to the left string. So we're going to have to do this. We're going to need to use a for loop, 0 is less than right dot length, since we're choosing one character from the right side, and then I++. So now we're going to update string left. So string left, so it's the new left side, equals the original left side plus right dot char at I. So the character on the right side that we just chose using the for loop. And string the right side is now, so we're now going to have to create a new string that's the right side, but without the character at index I. So we're going to have to do right dot substring 0i, which means that it goes starting at 0 and all the way up to I, but it's exclusive. And then we're going to have to add right dot substring I+1. So one character after that, so that we don't count it. And then this goes into the recursion part. We're going to have to call the entire function again within the function. So right equals left, right again. But the thing is, right now, there's nothing stopping the function, right? If we're not actually adding anything to the set, and we're not actually going to be like doing anything, this function is just going to run and it's going to be over, and there's nothing that's going to like output out of it. So what we need to do is add all of the strings that we have created to the set, right? Because we initialized the set over here. So since after all of this, the right side should all be just blank, because we're getting rid of these characters, and now the left side is going to be complete and the right sides are going to be blank. So what we need to do is, one way to know that our left side is complete is if the right side is blank. So if right dot length equals 0, right, then that means the left side is complete, which means that we can add the left side to the set. And remember that the recursion is going to end because of this for loop. Since right dot length is equal to 0, then this for loop isn't going to run. So the function it's going to stop calling itself at that point. So now we have to first call the function, of course. So recursion, an empty string, and the string s. Since the left side is at first empty, right? And then you're going to be adding the strings in order to create combinations of the characters. And then we're going to have to print all of these out, right? Simple enough. We have to print each string inside a set. But in order to do this really efficiently, we can use something called a string builder, which is going to gather all of the strings within set and then print them out all at once, because it turns out that println is really slow, so we use a string builder. String builder. So first we have to append size, right? Because we have to print out the size. And the size is the first thing we print out. So sb.append set.size. And then you also have to print append a new line, right? Append new line. And after that, for each of the strings, so let's say string p, set Then we also have to append that to the string builder. So string builder dot append t dot append a new line. Because we need to make a new line every time we add a string to the string builder. It doesn't do that automatically for you. And then the last thing we do is system.out.println string builder. And that should print out every single one of the combinations with the size first. So we can test this out now after I save it. Submit CSES 1622, then we submit it. And it was accepted. Yeah.